Bismillahirrahmanirrahim. Today we shall understand how to make 5-volt power supply from a big voltage like 24, 12, something like that. So in order to make 5-volt power supply, you need to understand what is Zener diode. The basic functionality of this Zener diode is to keep a fixed voltage across its terminal when you apply a bigger voltage across it. So for example, I select this Zener diode which maintain 5-volt across its terminal and 0.1 volt draw from it. We can understand from its data sheet. I will show later in this tutorial. So this is a 5-volt Zener diode. So if I apply 12 volt over here, it will maintain 5 volt. If I apply 24, it will maintain 5 volt. And one thing you should keep in mind, that always you have to select this R in such a way that the maximum current that flow through this Zener diode should be 0.1 ampere. That is written in its data sheet. So one question that comes in mind, what if I apply the load across this terminal? So if I apply a load from this terminal, just like that 5 ohm load, so what will happen? This R1, RA6 and R8 will make a potential divider, and 5 divided by 1K will reduce the voltage to 0.1 volt. So this Zener diode cannot make 5 volt from this 0.11 volt. Here you can see, if I remove this load from the Zener diode, here you will see 5.1 volt ampere. It maintains its terminal from the 24 volt. And I designed 1K in such a way that the maximum current draw from it is less than 0.1, so its working will be fine. So if I apply load with this terminal across this terminal, you will see that this will make a potential divider and voltage will be 0.11. So Zener diode, it is its working will be reduced and it will cannot maintain 5 volt from this terminal. So here is a Zener diode which says that its nominal voltage across that will it maintain is 5 volt, and maximum power dissipation at 5 volt is 500 milliwatt, which means it maximum current should flow that from this terminal is 0.1 ampere. So I select 1 kilo ohm, which 24 divided by 1K will reduce the current to 0.01 ampere. That is good enough for this Zener diode to work. BJT in my circuit. So you should need to understand the functionality of this BJT. Its functionality is very easy. When you apply 5 volt at the base with respect to this ammeter, it will just short these two terminals. This is the basic functionality of this BJT. So this is my load 5 volt and I want to maintain 5. This is my load 5 ohm and I want to maintain 5 volt across this load and 1 ampere through this load. So what I do, I just connect the collector of this BJT with the 24 volt. So if I apply 5 volt over here, it will conduct, it will short this terminal and the voltage increase from 0 to definitely it should increase 0 to 24. But the moment it cross 5.1, then this connection should be cut off, so that it should not increase 5. And the moment it decrease from 5 to 4.9, then this connection should be established, so that it's switching. This BJT will act as a switcher between these terminal. So the moment the voltage across 5.1, then it should the voltage 0 voltage should appear over here and it should be cut down. And the moment the voltage drop from 5 to 4.9, this connection should be maintained and voltage will be starting increasing. So for this purpose, I need a feedback at this terminal. So here I am adding some feedback mechanism at the pin 2. So what will happen? Initially output, the voltage at the output is 0. So here 0 volt appear over here, and when I run this circuit, 5 volt appear over here. So the voltage at the positive terminal is higher as compared to 2, So maximum voltage appear over here, and this will conduct, and the output voltage will start increasing. And when it will increase, when it will reach 5 volt, then 5 volt appear over here and 5 volt appear over here. So the output will be 0, because the moment it increase 5 volt, then voltage at the negative terminal will be higher and the output will be 0 from the functionality of this comparator, and this connection will break down and the voltage start decreasing. The moment it decreased to 4.9 and voltage at this terminal is 4.9 and here is 5, it will again conduct. Higher volt will appear over here and this will start conducting, and again voltage will be increasing. For this purpose I need a capacitor over here. So I will add some capacitor over here, just like this, so that it when this circuit will be cut off, it will start conducting this and start giving current to this load, and the moment it increase, it will cut down, and the moment it decrease the voltage, this will be the breakdown. This connection will be breakdown, and this capacitor will be start conducting this 5 volt power supply. So next I need to because the voltage range of this transistor from base to emitter is 5 volt. So here here 5 volt appear over here at the conduction point. So here maximum voltage should be 12. So so for this purpose I need this power supply for this comparator should be 12 volts, so that because when the voltage at the positive terminal is higher than negative, then here plus V appear over here. So in order to maintain 5 volt across this terminal, 5 to 7 volt, I need 12 volt power supply over here. For this purpose I shall add a potential divider over here. So here I apply 10k, which will maintain 12 volt from this 24 volt power supply, and I apply voltage to show you which voltage do I have and much current flow through this. First I will remove the load and show you the voltage that I have at the output. I have 5.19 volt at this at the output terminal. Now I will add some load over here and see here is 5, so maximum current should be 1 ampere and the output voltage should be 4.5 to 5.5. So if I run this circuit, you can see I have 4.6 volt over here and 0.92 ampere current that's being drawn through this circuit. So this is a very close to ideal, because only 0.4 volt drop at this higher load. Thank you.